The image displays a function reference table commonly used in signal processing in MatLab. Here's a breakdown. 1. Resample functions. Resample. Non-uniform resamples a non-uniform signal to a uniform sample rate. Example, sig equals resample sig txfs. Explanation. This function converts a signal sampled at irregular intervals to one sampled at a uniform rate. Resample, p by q times resamples the input sequence at p by q times the original sample rate. Example, sig equals resample sig pq. Explanation. This allows you to change the sampling rate by a fractional amount. Useful for interpolating or decimating the signal. 2. Align signals. Function. Aligns two signals by delaying the earliest signal. Example. xa, ya equals align signals xy. Explanation. This function adjusts the time delay between two signals so that they are properly aligned. Useful for signal comparison or synchronization tasks. 3. P-spectrum. Power spectrum. Displays the power spectrum of the signal. Example, P-spectrum sig. Explanation. The power spectrum shows the distribution of signal power over frequency, which is useful for identifying frequency components. Spectrogram. Displays the spectrogram of the signal. Example, P-spectrum sig spectrogram. Explanation. A spectrogram provides a time-varying frequency analysis of the signal. It's useful for signals whose frequency content changes over time, like radar or communication signals. 4. CWT, continuous wavelet transform. Function. Displays the continuous wavelet transform of the signal. Example, sig fs. Explanation. The wavelet transform analyzes the signal at different scales, making it useful for time-frequency analysis. It requires the wavelet toolbox in MatLab. 5. Low-pass filter. Low-pass filter. Applies a low-pass filter to the signal. Example, low-pass sig 10. Explanation. This filters out high-frequency components above 10 Hz, leaving only the lower frequencies in the signal. Low-pass with modified steepness. Applies a low-pass filter with a specified steepness of the transition band. Example, low-pass sig 10 steepness 0.95. Explanation. This adds an additional parameter to control the steepness of the filter, which defines how sharply the filter cuts off frequencies above the threshold. 6. Bandpass filter. Function. Applies a bandpass filter to the signal, allowing frequencies within a specific range. Example, bandpass sig 812. Explanation. This filters the signal to keep only frequencies between 8 Hz and 12 Hz, removing other frequencies. 7. Find local extrema task. Function. Finds local maxima and minima in the live editor. Explanation. This built-in task identifies peaks and valleys in a signal, which is useful for data analysis in various fields like radar, medical diagnostics, etc. Conclusion. This function reference is a handy guide for performing signal processing tasks in MatLab. It includes functions for resampling, filtering, aligning signals, and visualizing power spectra and spectrograms. These tools are useful in communication systems, radar, and other signal processing applications.